For all of human history, the moon has been our constant, silent companion. A familiar face etched into our myths, our poetry, our very dreams. We've gazed upon its craters and seas, imagined figures in its shadows. But for every moment you've looked up, an entire hidden world has been turning its back on us. A hemisphere so profoundly different, so scarred by cosmic violence, that it challenges everything we thought we knew about our closest celestial neighbor. And just recently, after more than half a century, humanity returned to glimpse its profound, forgotten secrets. We often mistakenly call it the dark side, but that's a profound misnomer. Every part of the moon experiences the cycle of sunlight and darkness. This isn't about light, it's about perspective. It's the far side, a place forever turned away from Earth, locked in a gravitational embrace known as tidal locking. Over billions of years, Earth's immense gravitational pull slowed the moon's rotation until its spin perfectly matched its orbit. The result? A cosmic ballet where one side perpetually faces us while the other remains eternally veiled. For millennia, this hidden hemisphere was a blank slate for our imaginations. What alien landscapes lay beyond our sight? What secrets did it hold? The first tantalizing answers arrived in 1959, not from human eyes, but from the Soviet Luna 3 probe. Its grainy, pioneering images revealed a stark, crater-pocked world, utterly devoid of the vast, dark volcanic plains, the Maria, that define the familiar near side. Scientists were shocked. The moon was profoundly off balance. Since then, robotic scouts like NASA's Lunar Reconnaissance Orbiter and China's Chang'e missions, including the historic Chang'e 4, which made the first ever soft landing on the far side, have provided unprecedented detail. But nothing compares to the human experience. And that's where Artemis II enters the story. Just recently, 4 extraordinary individuals became the first humans in over half a century to journey beyond low Earth orbit, carrying our collective gaze back to this alien landscape. The contrast is astonishing. When you gaze at the moon from Earth, approximately 31% of its surface is covered by those dark, relatively smooth volcanic plains we call Maria. But turn your attention to the far side, and that number plummets to a mere 1%. Instead, we find a rugged, ancient terrain, a chaotic tapestry of highlands and impact craters. This profound geological asymmetry, known as the lunar dichotomy, has been one of the moon's most enduring mysteries. Why is our moon so dramatically two-faced? The leading theory takes us back billions of years to the moon's fiery birth and its subsequent cooling. Imagine the early moon as a molten ball, covered by a global magma ocean. As it began to solidify, Earth, still a scorching inferno, radiated immense heat onto the side of the moon facing it. This kept the near-side crust warmer and thinner, allowing radioactive elements like potassium, rare earth elements, and phosphorus, collectively known as creep, to concentrate there. These elements generated internal heat, keeping the near side volcanically active for billions of years, creating the vast Maria we see today. The far side, however, was shielded from Earth's intense warmth. It cooled much faster, forming a crust nearly twice as thick. When colossal asteroids struck, they easily punctured the thin near-side crust, allowing molten rock to well up and fill the basins, forming the dark seas. But on the far side, the crust was simply too thick, too resilient. Impacts created craters, yes, but the underlying magma rarely broke through. It's a tale of two halves, shaped by proximity and primordial heat. Wait, but what if? This isn't just about surface features. What if the far side holds a direct window into the moon's very core? The South Pole-Aitken Basin, SPA, a colossal impact structure stretching 2,500 kilometers across and plunging 13 kilometers deep, is the largest, oldest, and deepest confirmed impact basin on the Moon. Formed over 4 billion years ago, this impact was so violent, so immense, that scientists believe it may have stripped away the crust, exposing material from the Moon's upper mantle. It's a geological time capsule, offering unparalleled insights into the Moon's internal composition and early history. This is the world the Artemis II crew recently experienced. As their Orion spacecraft swung behind the Moon, they entered the Cone of Silence. For approximately 40 minutes, they were completely cut off from Earth. No radio, no GPS, no internet. Just 4 humans, millions of miles from home, and the silent, rugged highlands of the far side passing beneath them. Astronaut Christina Koch vividly described the feeling of seeing these missing dark patches, the familiar lunar face replaced by something alien, as sensing something was fundamentally wrong with the universe. It was a profound moment of isolation, yet also of unparalleled wonder. Wait, but what if? This very isolation, this profound silence, is the far side's greatest gift to humanity? Because it's shielded from all of Earth's cacophony, our television signals, radio broadcasts, cell phone chatter, and even the natural radio emissions from Earth's ionosphere, the far side is the quietest place in the entire solar system. This makes it the ultimate location for a new frontier in astronomy, radio astronomy of the cosmic dark ages. The cosmic dark ages refer to a period from about 380,000 years to 150 million years after the Big Bang, before the first stars and galaxies ignited. During this time, the universe was filled with neutral hydrogen, which emits a faint, specific 21-centimeter radio signal. This signal, stretched by the expansion of the universe to very long wavelengths, is virtually impossible to detect from Earth due to interference. But from the pristine radio silence of the lunar far side, we could potentially peer back to the very dawn of time, unlocking secrets about the universe's infancy that are otherwise inaccessible. Artemis II was more than just a flyby. It was a pivotal scouting mission. The crew wasn't merely looking for spectacular views, they were testing the systems, refining the procedures, and gathering crucial data for the next giant leaps. They were, in essence, preparing the way for Artemis III and beyond, missions that will see the first woman and person of color land on the lunar surface, and ultimately establish a sustainable human presence at the Moon's South Pole. The South Pole, with its permanently shadowed craters, is believed to harbor significant reserves of water ice, a precious resource that could be converted into drinking water, breathable oxygen, and even rocket fuel. The far side, once a realm of myth and blurry photographs, is rapidly transforming into our next great frontier, a proving ground for humanity's expansion into the cosmos. We've spent thousands of years looking at one face of the Moon, content with its familiar glow. But the successful return of Artemis II reminds us that there is always more to discover, more to understand, and more to explore. The far side, with its rugged beauty, its profound geological history, and its promise of unlocking the universe's deepest secrets, beckons us onward. If you could have been one of the 4 people in that capsule, looking down at a world no one else can see, what would you have been thinking? Would you have felt the isolation or the boundless wonder? Let us know in the comments below. See you in the next one.